Hello, I'm Muhammad Helmi. Today I'll talk about the paper titled Reconfigurable Intelligent Surface Assisted Space Shift Keying. The title shows two topics, Space Shift Keying and RIS, or Reconfigurable Intelligent Surface. What is Space Shift Keying? Space Shift Keying is a type of index modulation, and it works by putting information on the index of transmitting antenna. And it only works each time, only one active antenna works each time, and this increases spectral efficiency without occupying more bandwidth. What is the reconfigurable intelligent surface or the RIS? It's a passive elements works as a reflector for the transmitted wave and estimate the phase change through the channel. And the paper assumed two types of them, intelligent and applied. The intelligent has full information about the environment, as shown in the first equation. Here, I don't know if there is a pointer. It applies the absolute values of the channel. And the second one is applied, which is the worst case, and the practical part assumed there is no information about the channel at all. And the paper assumed the elements phase that estimated in the RIS will be fixed equal 0. Showing the information here is the combined between RIS and space shift keying that the paper is talking about. And the last two equations is the maximum likelihood that used to estimate the index of the active transmitter. Here is the system. There are many index or many transmitter, and the RIS, and ends with one receiver at D. Later we will explore that there is a possibility to be more than one receiver. Okay, what is the motivation by this system? As we said, it's the power spectral efficiency and avoiding loss happened through traditional SSK due to large field. So this is a simulation. As shown, it matched almost the one in the paper, but with zeros. This is because the small number of bits. If we increase the bits until 100 or 1 million or more, it will reach the same graph. And the performance showed that with increasing the number of number of elements in RIS, it will decreasing the bit error rate. Here is another graph showed the performance between or the comparison between RIS combined with SSK and the traditional SSK. With third graph with the upper approximation of the analytical part of combined system. Here is the performance using the phase error. Actually, using a small error in the RIS element will decrease the bit error rate, increase the bit error rate, increase the error, so decrease the bit error rate. But as shown here, with the small number, with small SNR, we can achieve higher high bit error rate. So, and the change in the between n and the phases is slightly small. What is the performance on the pass loss? Actually, the paper assumed there is a near field between the RIS and the transmitter, depending on the equation 4 pi lambda over d squared. So it will decrease by d power 2, and the gain, and there is a cascaded gain between for the first channel between the transmitter and the RIS, and between the RIS and the receiver, multiplied by the number of elements power 2 in the RIS. And for traditional, it's only one gain of the channel multiplied by the transmitter number of transmitter. So the bus loss is increasing by increasing the number of elements, but however that it's comparing for the right graph above, comparing to the traditional SSK, it's still low, and also increasing the N is uniformly increasing the bus loss. The left graph shows that showed the different frequencies with different number of elements in depth, and also we fixed the D, which equal to total D, which equal to 3 meters, and the distance between the transmitter and the RIS equal 0.6 meter. As shown here, the curves almost match the one in the paper. Finally, the blind RIS, or the blind reconfigurable intelligent surface with SSK, which is near to the practical part, as there is no information about the channel. The results here showed the same intuition about the efficiency of the combined system over the traditional SSK, as shown in the middle graph. All the ends, all the RIS system with different ends compete with the traditional SSK, which in black, and the one in the right shows different criteria that we could use to enhance our system by increasing the number of received antennas. So it increases the performance of traditional SSK and the performance of the combined system also. But the combined system will be better as shown before. So in conclusion, RIS combined with SSK is energy efficient compared to the traditional SSK, and the phase error at the RIS degrade performance, but not severely, as shown in the graphs. Third, the path loss could be a serious challenge with increasing N, as the N increased the path loss. But as shown, it also better than the traditional SSK. And increasing the number of the receiver enhances the detection for both traditional and SSK. And thank you.